Okay, so this video right here is on AP question number 3, which is a standard procedure for isolating a compound that's been made. So let's take a look at the procedure really carefully. All right, so they add a metal, and then they add some I2, and then a reaction occurs between the M and the I2 upon the addition of water. All right, and what they show down here is they show leftover M. So what they're saying is here, okay, is that M is the excess reagent. So all the iodine reacted, okay? And then what they do is they collect the solution either by filtration, okay, or by decanting incredibly carefully, and then they heat it and the water evaporates and they collect the solid Mi2 that's made. So this is your base reactant. M plus I2 gives you Mi2. You had a little complex process in which the Mi2 was dissolved, is a soluble compound, was dissolved in the water, and they either filtered it out or they decanted it, and then they heated the test tube, which contained the solution, and removed by heating up the water evaporated, leaving behind the solid Mi2. All right, what's in the data table? You have a mass of a beaker, you have the beaker plus the metal, the beaker plus the metal plus the I2. The reality is, okay, what you're supposed to read from this is this. You really don't know you know exactly one thing. You know exactly how much I2 is being put in. You also know how much metal was put in, but the idea is the I2 is a limiting reagent because you know there was leftover metal. And that really is the key to the whole question. You know the mass of the I2 that was consumed. You know the mass of the I2 that's in the compound that was made, right? So this down here below, since it stayed the same, that is the mass of the Mi2. Okay, so you know the mass of the I2 and the mass of the Mi2. You don't know the mass, you know the mass of the original metal that was put in, but it really doesn't matter to you at all. Okay, so it says, given that the M was in excess, calculate the number of moles of I2 reacted. The idea is you assume all the I2 was reacted. That's the assumption. Okay, that's the idea of a limiting reagent. So all you're going to do here basically is get the difference in those two numbers there, convert that into a mole. Okay, and make sure you're clear because the formula is I2, so when you get to use the right GFM clearly for this. All right, then it says calculate the molar mass of the metal. Remember what GFM is. GFM is grams per mole. But here's the thing: you know how many grams of Mi2 you have, don't you? Right? And you know for every 1 mole of this stuff here, for every 1 mole of Mi2, right, there was 1 mole of I2. It's a one-to-one relationship, right? So the key idea is to use the answer for A for B. You know how many moles of Mi2 you have. You know the mass of Mi2 you made. Now you're going to get a certain number of grams per certain number of moles. Divide through, you get the grams per 1 mole. And as soon as you're done with that math, okay, you get to what I think are some easier questions, okay? C, propose an experimental test you can perform that could be used to support the hypothesis that the substance produced was ionic. Okay, what are the properties of an ionic substance, okay? You just did a unit on that. Talk about its solubility or its melting point or conductivity, something about ionic substance, or it's is it hard, brittle, malleable, whatever. Any of those things probably would be reasonable answers in terms of determining that it was an ionic compound, right? Based upon its physical properties. Okay, the next part of the question deals with why is I2 a solid versus bromine is a liquid. All right, you need to talk about IMFs. I'm not going to tell you what type of molecule I2 is and Br2. You should know, and you should know which type of IMF to talk about and which ones not to discuss in the context of these types of substances. All right. The next thing that you have is a redox question. You're going to have to flip one of these. Obviously, this will not be on your AP exam. Okay, and remember, only reactants can react. So if you were going to do this, you're going to pick a reactant, and you're going to have to clearly, you're going to be making I minus. We know that for a fact according to the overall reaction, okay, which is on right. So you're making I minus. And either this is going to be reactant or, this is going to be the reactant because you have to flip the other one, which I'm going to give you, and I'm going to leave it right there. Okay, the net ionic reaction should not include sodium when you're done. Again, both E and F are off the table, but you should know a little bit about net ionics. So just briefly remember, alkali metals are never going to be in net ionic reactions. That's a good thing to know because they could throw that in there.